Now, in this video, we are going to discuss about comparison of solid and hollow shafts subjected to pure torsion. So here, in the first case, we are going to consider the comparison of torsional strength of hollow shaft and solid shaft. So let us consider a hollow shaft and a solid shaft which is made out of same material, length and weight. So what is weight? Weight is nothing but the volume into the specific gravity or the specific weight of the material. So what is volume? Volume is nothing but area into length into specific weight of the material. So then if capital A is the area and L is the length and small w is the specific weight of the material, then it will going to be A into L into W. That is the weight of the shaft. As the weight of the shafts are equal, so that means that is weight of the solid shaft will be equal to the weight of the hollow shaft. So that means if you are considering the weight of the solid shaft, which will going to be area into length into specific weight. So what is the area of the solid shaft? The area of the solid shaft is pi d square by 4 into the length is Ls, that is the length of the solid shaft, and also the small Ws, that is the specific weight of the material, which will be equal to pi by 4 into d naught square minus di square. So that is because the area of the hollow shaft into the length of the hollow shaft and the specific weight of the hollow shaft. As he says, the length is same. Since as the length and the material of the shafts are same, so what happens? Ls will be equal to LH and also Ws will be equal to WH. So now, so both Ls and Ws and LH and WH will going to be get cancels. So, and pi by 4 and pi by 4 will get cancels. Therefore, what happens? It will going to be d square will be equal to d naught square minus di square. So considering the common factor of d naught square, 1 minus di square by d naught square, so that will be equal to d naught square into 1 minus k square, where k will be equal to the ratio of internal diameter to the external diameter, that is di by d naught. So therefore, what happens with the d will be equal to square root of d naught square into 1 minus k square. So d naught square root is d naught into square root of 1 minus k square. So that is the diameter. Now what is torsional strength? The torsional strength is given by T by tau will be equal to Jp by R. So what is the polar? It is the ratio of polar modulus or the polar moment of inertia by the outer radius. So that will be equal to Zp. So therefore, the torsional strength of the hollow shaft divided by the torsional strength of the solid shaft. Why? Because we are comparing the hollow shaft with respect to the solid shaft. So therefore, torsional strength of the hollow shaft divided by the torsional strength of the solid shaft will be equal to sectional modulus of the hollow shaft, that is ZPH, divided by ZPS, that is the sectional modulus of the solid shaft. So what is the sectional modulus of the hollow shaft, which is pi by 16 into d naught to the power of 4 minus di to the power of 4 by d naught. The entire thing is divided by pi by 16 into d cube. So that will be equal to pi by 16 will get cancels, and taking the d naught to the power of 4 as the common factor. So therefore, in the numerator, 1 minus di by d naught whole to the power of 4, that divided by d naught into d cube, where d naught comes to the denominator. So d naught to the power of 4 get cancelled. So therefore, you will going to get it as d naught cube into 1 minus k to the power of 4, where k will be equal to di by d naught, that divided by d cube. So what is d cube? You can write d cube as d square into d. So therefore, it can be written as d naught cube into 1 minus k to the power of 4 divided by d square into D. So substitute the value of D which we have got from our earlier this step. So that is D naught cube into 1 minus k to the power of 4 divided by D naught into square root of 1 minus k square into D naught square into 1 minus k square. So D naught square into D naught will go to become D naught cube, and that D naught cube and numerator D naught cube will be get cancelled. Therefore, it is left out with 1 minus k to the power of 4 divided by square root of 1 minus k square into 1 minus k square. You can write 1 minus k to the power of 4 as 1 minus k square plus 1 into 1 plus k square. So that divided by square root of 1 minus k square into 1 minus square root of 1 minus k square into 1 minus k square. So 1 minus k square and 1 minus k square gets cancels. Therefore, it is left out with 1 plus k square divided by square root of 1 minus k square. Therefore, that is the torsional strength of the hollow shaft divided by the torsional strength of the solid shaft will be equal to, it is the ratio of 1 plus k square divided by square root of 1 minus k square. So the ratio is always greater than 1 because 1 plus k square will going to have a greater value when compared to the square root of 1 minus k square. So therefore, you will going to get the ratio will be always greater than 1. So where k will be equal to di by d naught. From this, we can infer that the hollow shaft is stronger than solid shaft when their material, length, and weights are same. Thank you.